just about all statistics software is going to give us probabilities for binomial experiments. Specifically, it's going to give us probabilities for the probability mass function, PMF, and the cumulative distribution function, CDF, which is exactly why we covered those right at the beginning of this unit. So, again, that's going to give us the probability that our random variable equals some specific value, or the probability that our random variable is less than or equal to some specific value. There's other things we might be interested in. For example, the probability that it's more than some number or between two numbers. So we need to figure out how to put these two things together to get what we need. In general, I'm going to use this PMF to do just what it does. Give me a probability for one specific value. If I want to find the probability of getting exactly 4 heads out of 20 flips, then I use this one directly. That's what it's for. Whenever I'm finding probabilities for a range of values, I'm going to be using this CDF because it'll give me the answer far more directly. So what I really need to do is just figure out how to use this thing when I'm looking for a range of values. So let me go through a few tricks that we can use to get things written in the form of a CDF, because that's what I'm going to need to do. Whenever I've got some other kind of probability besides equals, which I use the PMF directly, I'm going to need to manipulate that probability so that it has a less than or equal to symbol in it. Okay, so let's look at some possibilities that we might have. So first one, the probability that our random variable is less than some number. Okay, so I've got specifically the probability that our random variable is less than 5. Well, we've been using this idea of using counting numbers a few times before. So less than 5 means 4 or less, right? That'll give us kind of an example to work with so that we can do this thing in general. So whenever I need to find the probability, and again, this only works for counting numbers, or counting variables, the probability that my x is less than some number, let's say k, is the probability that it's less than or equal to the number 1 less than that. So, if I'm trying to find the probability that my variable is less than 13, that's exactly the same as the probability that it's less than or equal to 12. These are exactly the same numbers, right? If we're working with whole numbers, less than 13 is exactly the same as 12 or less. So that's the first trick. If we've got a less than, the way we get it to be less than or equal is just subtract 1 from it. All right, let's look at another one. So here we want to find the probability that our variable is more than some number. Okay, so to do this, I want to look at complements. So whenever I've got a greater than symbol instead of a less than symbol, I want to flip the direction on that by doing the complement. So let me show you how this is working. All right. Let's say we're looking for the probability of getting more than 3. So let's look at a number line. And again, we're counting here, so we start at 0. That's the lowest I can have. Then 1, 2, 3, 4, 5, right, so on. All right, so the probability that we're more than 3 would mean all of these, right? More than 3 would mean 4, 5, 6, 7, 8, 9, and so on. So I want to look at the complement of that to flip the direction on this, because remember, I need to somehow transition this to be a probability that's less than or equal to some number. Well, as I look at this, to get the complement over here, the complement of more than 3, right? All the other numbers that are left over, once I eliminate these, are 3 or less. Well, that solved it right there, right? I went from greater than to less than or equal to in one step. But it's actually maybe simpler than trying to draw out this whole number line. That certainly does make sense. But let's do something that's just kind of a basic math thing that you probably forgot from years and years and years ago. There's only 3 things that can ever happen when we're comparing 2 numbers. One could be less than the other, one could be more than the other, or they could be equal to each other. These are the only 3 things that could ever happen. It's called the trichotomy principle. So, if I'm looking for the complement of greater than, I just eliminate that and look what's left over, less than or equal. So let's use that for another one of these. The probability that my variable is greater than or equal to 4. All right, I haven't explicitly given this to you in the notes yet, but let's look at just using that kind of trichotomy idea again. So I could be less than, greater than, or equal. Well, I've got a greater than and equal built into here, into the greater than or equal to. That only leaves less than. So, how do I do this? It's 1 minus, and I should have included the 1 minus here. I just didn't use an equals. So equals 1 minus, right? Because I'm looking at the complement, and I'm using the complement rule here. This is going to be 1 minus the complement of this, which is that this y variable is less than 4. All right, well, I'm almost there. I just said that if we need to go from less than to less than or equal, all I have to do is just take 1 away. So less than 4 is the same thing as 3 or less. And now finally, I have it written in the form that just has a less than or equal. I can use the CDF, cumulative distribution function, out of my software or calculator, and it'll give me what I need. Okay, so there's just one more that we really need to talk about. So we've already dealt with less than, greater than or equal to. The other one that comes up fairly often is between 2 numbers. The probability that we get between 3 and 5 people coming to my office hours, let's say something like that. So here I feel like the English is not extremely clear, and more importantly, our minds have been messed with by previous math classes enough that between is kind of a terrifying thing. Like, do I include, when I say between 3 and 5, do I include 3 and 5? I feel like usually in plain English, I'm including that, right? So when I say, when someone asks me, like, because I went to a party last night, like, oh, about how many people were there, and I'm like, oh, there were between like 20 and 30 people. I mean, there could have been 20, there could have been 30, or it could have been anything in between. Usually I'm including those numbers when I say between A and B. Okay? So let's talk about that. First off, that means in my class, when I'm talking about finding the probability of being between 2 numbers, I'm including those endpoints. So let's say I ask you about a probability of between 3 and 7. I don't know. Between 3 and 7. What I mean is it could be 3 or more, and it could be 7 or less, right? So it could be any of the numbers between 3 and 7 or 3 and 7 directly, if it is one of those. So how am I going to do this? Well, let me demonstrate. Again, with just a number line real quick here. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, so let me just see, what am I going to get if I just find the CDF value for 7? That's going to give me the probability of 7 or less. Right? So it's going to give me the probability of any of these numbers from 0 to 7. What am I going to have to subtract from that in order to just get what I want? Well, I only want from 3 to 7. So this 2, 1, and 0, I want out of there. right? So this is what I'm going to have to subtract away. Well, that's just the CDF for 2. And this thing is the CDF for 7. So what I actually need to do is find the probability of being less than or equal to 7. Remember, that's written in CDF form. It's got a less than or equal to sign. That's what we're going to get out of software. And I'm going to subtract the probability of getting 1 less than this, right? So 2 or less. That leaves me just 3 through 7. That's what I wanted. So that's what we're going to do when we're looking for probabilities of being between two numbers, is I just find the CDF for the bigger number and then subtract off the CDF for 1 less than the lower number. That's how I go through that. We're going to need some practice with this, but realistically, after a while, it becomes a little bit formulaic. Just make sure you've got these tricks in your notes so that you can quickly reference them, and then it's actually just a matter of doing this enough times that it becomes a simple task for you.